Question number 31. Which of the following statements is or are correct with regard to 3D block elements and their compounds? Statement A. Among the 3D block elements, scandium is not considered as a transition element. That statement is wrong actually, but in the earlier A-level papers they took this statement as a correct statement because the definition for the transition element in the previous syllabus was any element which contains unpaired d electrons in their metal ions, but the new syllabus definition contains a transition element which has unpaired electrons in the element or an ion. So if an ion or an element has unpaired d electrons, it's a transition element. So according to that definition, scandium is a transition element, but only zinc is not a transition element. It's a non-transition element. Non-transition element from the 3D series. Zinc is the only non-transition element according to the new syllabus. But in the previous syllabus, there were two non-transition elements in the 3D series. That was scandium and zinc. Therefore, this statement is incorrect. Let's write down a transition element. Please remember this definition. An element which contains unpaired d electrons in either the metal or the metal ion. Any metal ion, it doesn't matter. If even one metal ion has unpaired electrons, that is also considered. So the first statement is incorrect. Statement B. The radii of atoms scandium to copper decrease from left to right. This is a true statement. The radii of the 3D elements variation looks like this. Radius, atomic number, it goes like this. Scandium to copper, it decreases, and then vanadium increases. Zinc increases. Now the reason that the zinc has a higher radius because it has the highest shielding effect from the inner energy levels. So scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So scandium to copper, it decreases. Statement C. Nickel ammonia complex is blue in color, whereas zinc ammonia is colorless. That is correct. There's another blue color complex, that is copper ammonia 4. Copper ammonia complex and the nickel ammonia complex are considered as deep blue color complexes. Both of these are deep blue. Now zinc compounds are colorless because it doesn't contain unpaired electrons. Statement D. The IUPAC name of K2NiCl4 is dipotassium tetrachloronicolate 2. This is actually wrong because this is an ionic compound. It is like this. nickel Cl4 2 minus ion and potassium ion are exchanged in their valencies. So it's an ionic compound. When you're writing ionic compounds, we don't use this di, tri, tetra thing. It is used only for covalent compounds. For example, let's say K2O is potassium oxide. If this is Cl2O, this is called dichlorine monoxide. The difference is they both seems like the same structure having compound. Both of them have two elements and an oxygen, but this one is a metal, this one is a non-metal. If metal is there, it's an ionic compound. It's a non-metal is there, it's a covalent compound. That's the general rule. For ionic compounds, we don't write dipotassium monoxide, we just write potassium oxide. For covalent compounds, we have to mention the amount of the electropositive atom and the amount of the electronegative atom. So there are two chlorines, so this will not be named as chlorine oxide. This is just called as dichlorine monoxide. So that's the difference. Since this is an ionic compound, dipotassium is wrong. It should be named as potassium space tetrachloronickelate 2. Actually, it's not be the tetrachloro, it should be tetrachlorido as well. According to the new IUPAC rules, it should be tetrachlorido. So there are two incorrect mistakes here. Therefore, the answer will be B and C. B and C means second answer. Answer is 2. Let's move on to the next question.